Neural control of exercising muscle. Before we start our topic for this morning, let us first read a Bible verse that will be seen on 1 Corinthians 12 to 13. It says, "The body is a unit, though it is made up of many parts, and though all its parts are many, they form one body. So it is with Christ. For we were all baptized by one Spirit into one body, whether Jews or Greeks, slaves or free, and when we're all given the one Spirit to drink." What happens to neural control during exercise? So the answer is, the muscle blood flow increases in proportion to the intensity of activity, despite concomitant increases in sympathetic neural discharge to the active muscles, indicating a reduced responsiveness to sympathetic activation. So this are the summary of our overall topic. So first, the present review examines the control of muscle vascular conductance by the sympathetic nervous system during exercise. Evidence for tonic sympathetic neural control of active muscle rests on three findings. The first one is directly measured muscle sympathetic nerve traffic is increased. Second, spillover of noradrenaline from active muscle is also increased, and withdrawal of sympathetic outflow to active muscle, either by acute blockade of its sympathetic nerve supply or by reflex inhibition of sympathetic nervous activity, raises muscle vascular conductance via inhibition of tonic vasoconstriction. Number 3 is loss of tonic sympathetic control of muscle vascular conductance during mild to severe exercise causes marked hypotension despite maintenance of a normal cardiac output. The fourth one is the extent to which active muscle can vasodilate in intact animals appears to have been hidden by tonic vasoconstriction. This vasoconstriction appears to be minimally affected by metabolites in oxidative red muscle, but may be inhibited in predominantly glycolytic white muscle, owing to different spatial distribution of hand adrenoceptors in the two muscle types and to the different susceptibilities of the two receptor types to interference by metabolites. And the last one, the reflexes causing vasoconstriction in active and inactive muscle are unknown. One hypothesis is that a flowing sensitive muscle, chemoreflex, raises sympathetic outflow to reduce accumulation of muscle metabolites causing by mismatches between muscle blood flow and metabolism, called flow errors. Another hypothesis is that the arterial baroreflex corrects mismatches between cardiac output and vascular conductance called pressure errors. This review argues for a dominance of control by the baroreflex based on the following observation. The first one is the arterial baroreflex is essential to the normal rise in sympathetic nervous activity and arterial pressure at the onset of exercise. The second one, during submaximal exercise, a functioning arterial baroreflex is required to maintain tonic sympathetic activity and prevent arterial hypotension. And the third one, whereas the muscle chemoreflex may be needed to guard against hypoperfusion of active muscle, the arterial baroreflex must oppose hypotension by initiating sympathetic vasoconstriction to oppose muscle vasodilation. So that's all. Thank you so much and God bless.